Hello and welcome back once again. We're coming to you from the Coliseum in the downtown core, and as you can see we have a large studio audience. The topic today is probability. Let's begin. This presentation 4.1, a multi-part series in statistics. Now we've illustrated here several websites where you can check out the notion of probability. We have here in the yellow, this is the Google site. This is the Pearson site, and you can see here in the yellow one definition. And this is the Wikipedia site, and again a definition. Now we're going to look at the frequency concept of probability. If you toss a coin randomly, and it's a fair coin, probably with head and tail is a half each. And we put here for 20 trials, we've listed the head-tail sequence. And if we look at 100 trials, we can see here the probability of heads in stages of 5, 10, 15, 20. You can see that they tend to jump around but converge towards 0.5. This is called long-term or long-run probability, with everything else being equal. Now we're going to look at the experiment whereby we toss two coins, and we're going to use a tree diagram. And the first coin can be heads or tails, with probably a half each. Second coin can be heads or tails. See them coming on the screen here. If we look at these sequences, H1, H2, and so on, these become the simple events constituting what we call a sample space. The probability, of course, we simply multiply these numbers together, and in each case the probability is 1/4, and these are called equally likely cases. Now if we look at exactly one head, we can see there's two cases here, and we can write them out algebraically, and then using the probability concept, coming up with 1/4 plus 1/4, or 1/2. There should be a plus there. Probably H1 and T2, simply multiply them together, of course, is 1/4. T1 and T2 is half times a half, or again 1/4. These are independent events. Now we're going to look at two-stage experiments. We're going to look at electronic parts made in a manufacturing center, where the probability of a defective part is 20%, or 1 in 5. Probability of good is, of course, 4/5. We have here that the first component, the first one, randomly selected, could be good or defective, with probability 4/5 and 1/5. We're putting these on the screen here. The second part could be good or defective, with the same probabilities here. Now if we look at these sequences, the sample space, G, 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 G1, G2, G3, see them coming on the screen here. These are various combinations of items you can get, good and defective. And this constitutes the sample space. So to get one defective, you can see here 2 good and 1 defective. And this is a sequence if you wish. Now there's another sequence here, good, defective, good, or you can have defective, good, good, with these probabilities, and pause the screen and write these down, and this becomes the total probability, or 3 times. Now if we compute this value, 0.384, exactly 2 defectives, you can see them coming on the screen here. Write these down, the probabilities coming up here. As you can see, there's 3 ways. Now to get 3 defectives, of course we have them on the screen here, this bottom one, 1/5 times 1/5 times 1/5, or 1/5 cubed. Now we're going to look at the tossing 2 dice notion, and we're going to look at pairs such as this, and we look at the sample space. They'll come on the first die, they'll come on the second die. You see them coming on the screen here now. And this constitutes the sample space. These are called elementary events, or simple events, and that they're all equally likely. The probability of 6 and 3, of course, is 1/36. We simply multiply them together, 1/6 times 1/6. So the sample space is 36 equally likely events, probably getting a sum of 4. You can see here is there's 3 ways, 3 to 36. You get a sum of 7. these 6 items on the screen here, 6 out of 36. And the probability that the second die is even, you can see here, in each of these cases, the second die, is an even number. So we have 18 out of 36, or 1/2. And that's the end of presentation 4.1. We ask you to take notes as required and go to section presentation 4.2.